All right, what's up, everybody?
Yeah.
Happy Monday. Looks like OBS had an update, so let's make sure everything works.
Disqualified.
It's always something that'll break. And is YouTube? YouTube is streaming. Okay, great. Cool. Well, it says my connection is poor. That's great. Love that. Thank you, OBS. All right, let's see. Another week, another set of schools are probably starting up. I don't think UCLA starts till like mid-September. Let me actually find out when that was. They wanted me to teach a second summer session. I was like,
emotional, damn it.
It was a lot of stress doing one of them. I can't imagine doing back-to-back with like no break or anything. Let me see. UCLA fall quarter 2026. What is their schedule? September 21st. Damn, that is so late. And sorry, instruction doesn't begin till the 24th. It's always really weird. They start on a Thursday. Like, who wants to go to class on a Thursday and then like we got Friday and that's the weekend? Like, no. Doesn't make any sense to me. Like, just start it on Monday, dog. Otherwise, like, Thursday and Friday is just a joke. Like, no one's going to do anything. But yeah, okay. It looks like end of September. Should pay me more if they want me to do another. Yeah, honestly, yeah, the pay wasn't like super great. Yo, Waffle Roll. It is International National Waffle Day, Waffle Walrus. Yeah, did you see the notification? You're like, bro, I have to show up. I think it is seriously National Waffle. I have a script that just like figures out like what national day it is for everything, and then I just pick which one I think is fun. But yeah, National Waffle Day is the 24th, and that is today. Nice. The notification worked. It got you, Waffle Walrus. Do you have a reason that you really like waffles? I saw it mid-plank and I had to stop by.
Oh, yeah.
Glad you're doing some exercise mid-plank. I'm debating going to the gym today. I have Burning Man coming up in like a couple days. Like four days I have to leave for Burning Man. And I'm debating about whether going to the gym or frantically packing is worth more of my, better use of my time. So, but I'm glad you're doing planks. Planks are great. Great for core. Always choose gym. Yeah, maybe I'll go for an hour at least. I'll go do some cardio and like lift a couple of like quick weights. Well, Wikipedia says it's tomorrow. Well, this seems to say the 24th, Jeff.
My name is Jeff.
Okay, I guess the Swedes or whatever celebrate on the 25th. Okay, but why is Google saying it's the 24th? This says, okay, so the U.S. Waffle Day, National Waffle Day, is the 24th. Because apparently, in 1869, Cornelius Swartout of Troy, New York, received his patent for the waffle iron. While waffles existed long before then, the invention made waffles more readily available. Yeah, so I think waffles are probably like a Danish thing before anything. Yeah, but, whatever, Belgian waffles and stuff. But apparently the invention of the waffle iron, the thing that creates these beautiful squares of syrup. Yeah, USA.
That's dope.
Yeah, USA, dude. That's pretty cool. I do like waffles. I mean, if people ask me waffles versus pancakes, always waffles. Waffles have like the texture. They got the crunch. What's up, Dream? And then they can like hold syrup and stuff. They're quite great. I am a big fan of waffles. Pancakes, like the syrup just either like soaks them and they get like soggy, or it just like runs off the side. Yeah, screw Europe.
Oh, brother, this guy stinks.
I like Europe though. Europe's great. But yeah. But yeah, waffles are quite old. Anyways, all right, let's see. So yeah, I think today might be the last stream of the week. I might do one tomorrow. Yeah, maybe I'll do one more stream tomorrow. But then like Wednesday, Thursday, Friday, yeah, I gotta start packing really. Yeah, I have like no time. USA. Exactly. So yeah, all right. I'll make an executive decision right now. I'll do one more stream tomorrow, but then I will probably be gone for the next like 2 weeks. So I know Zach's been on vacation or taking a break with this August, so he'll bring back up the reins, I think, for when September starts. We can always check. Let's go see what's on the calendar. Calendar always tells us what's going on. So here we go. Oh, looks like the Summer of Math exposition is still happening. The reviews are still happening. Great. Look at all this. JC did some reviews yesterday. That's great.
Oh, yeah.
Oh, I'm sad I missed JC's stream. I love JC. I'm glad he's back to streaming. A-Lift did some today. Looks like tomorrow Eric's doing some. Penn Center's going to do some. And then cool. We'll have... Yeah, I still have this one on the calendar. We'll do a stream tomorrow. You previously talked about letting other people come into your stream. I really have. Yeah, I've thought about like if people just wanted to use my stream key to like just stream. I totally would, but I don't know if anyone has really like stepped up to wanting to do it yet. I did get a notification from TikTok. Our last stream apparently got us like soft banned. They said we were promoting. Dude, I hate when you get these warnings. It's not a permanent ban. It's like I just can't stream on TikTok until the 26th apparently, and I'm like, why? It says like marketing prohibited like things like gambling and addiction, and I was like, I don't think I was marketing that, you know. I don't know. I mean, we do speak our mind here on the stream, and we do say things I guess sometimes that would maybe trigger some automatic bots, but that's why we're not on TikTok today. So, well, what do we have here? Well, we have a stream that helps you out with math and science homework. We do a lot of like free tutoring during the year. And if you ever want to submit a question for us to go over, there's a website here, actualofficehours.com. Just type in your username, give me a screenshot, hit upload, and we may do it during the stream here. That's what happens. I need to get back to like making content. I'm going to start doing that more when I get back from Burning Man. I think that'll be like one of my epiphanies. I also like resigned from my tech job yesterday. It was just becoming like too much. There's too much chaos, and I know it's been like affecting me, so I decided it was best to just walk away from that. So I will be job hunting as well for some more stable employment. I mean, that was stable employment, but it hurt my soul a lot being asked to do certain things, and I was like, yeah, I don't really like doing this. So, but in life, if something feels off, I say fuck off. Like, it's okay. And they agreed to at least pay me for the next 2 weeks, so I have some sort of little bit of a cushion before I really got to figure out what's happening in September.
Emotional, damn it!
Anyways, you nominate Waffle Walrus. Yo, there's JC. Yes.
Good job.
Yeah, you are JC. Yeah, I would let JC take my stream, dude. JC, you want my stream? I'll give you my stream key if you want. JC, I trust. But yeah, I would need to have like some sort of trust of whoever the streamer is, because as I'm seeing, these platforms are getting more and more restrictive about censoring and things, and I don't want to like tank my whole account because whatever happens. You would, Loki? Yeah, cool. Yeah, I'm down, dude. We could say actual education featuring JC, the JC stream for like next week, because yeah, tomorrow will be my last stream until probably September 8th. I'm gonna be in the desert for like a week and a half, and then I need to come back and like probably regain my health and fortitude. But yeah, JC, DM me if you want. Yeah, I'm happy to, because we have an audience. We have lots of people here. It's only one me. It's only one me to do things. Why am I going to the desert? It's for Burning Man. It's a big. You can't call it a festival. People get upset if you call it a music festival, but it's like an experience. It has a lot of music festival aspects to it, because yes, there's music, there's lots of people, there's camping, there's stages, but it's more than that, because there's not really any infrastructure for it. When you go to a festival, there's like a concierge, there's like there is a med center at Burning Man. There has to be. But you have to like provide for yourself. You have to like put up your own infrastructure. You have to bring your own water. You have to bring your own food. There's no money. It's very unique. This will be my 4th year in a row doing it. I think after this year I am going to take a break. just because it takes a lot out of me. I love it. I think it's a great experience, and it really, for me, it's a big confidence boost in reminding myself I can do things, and humanity can come together and like do things, and be productive, and like, it's not sustainable, of course, because everyone's just being generous for the whole week. Everything's free. Everyone's trying to help out and do as much. Eventually, like, someone would need to pay rent, right? So,
Disqualified.
but for that week, it's truly one of the most unique experiences ever. I know it sounds cliche and whatever, but go do it. I say, go do it, and come back and tell me whether it wasn't. I guarantee you probably say it was. But yeah, that's what I'll be. I got to start packing for that today, really, but I'm gonna really be out of commission probably starting Wednesday, because you got to survive. The elements are like trying to kill you. It's like, it's very hot. It gets very windy. It's like 60, 70 mile per hour winds. Sometimes it'll sometimes rain. My first year we got flooded in. We couldn't leave for like an additional 3 days. It was pretty crazy. And yeah, there's all the elements. So it reminds me a lot of Boy Scouts. So I liked Boy Scouts. Okay, so cool. Yeah, good, Dream. You submit your question. Good. Now, Dream. Just to reiterate, you have to be present while we do your question, and you also have to be able to interact while we do the question. Yeah. For you to like get credit for the question. Yeah, it's not just like dump a question on Dr. Gold and have him do it. Like, the whole part of this stream is for you to learn. So make sure you're paying attention. Make sure you're learning. Last time I was working on other questions at the same time. Yeah. Well, don't do that. Like watch the stream. I'm here. You know, my time is limited. You have as much time as you want to do your questions, but my time is not forever. Okay, fine. Yes, my specialty is physics. Yeah, my PhD's in physics. But I would say the majority of what I teach is math, because that's the universal class everyone takes and everyone needs help with. So I would say I teach the most, probably calculus. But my PhD's in physics. I really enjoy teaching, and I've taught physics at the university level a couple times, or 3 times now. So I really enjoy teaching physics, but we mainly do math. And then I love chemistry. Chemistry is like my second favorite.
Good job.
But JC's the real expert at that. JC's the real chemistry expert. Physics. I might be back when Ian. Yeah, please do. I teach E&M. Like, I taught a summer E&M course at UCLA. Like, literally ended 2 weeks ago. So E&M is one of my favorite things in physics to teach. If you need help with that, come on by. We'll help you out. Math just makes more sense. I feel like physics makes more sense because there's a physical intuition behind it, but teach everyone. Yeah, for sure. I got you, Waffle, dude. Okay. With that being said, let's start working on some questions. I think we can start working on some questions today, right? Cool. All right. Let's start off the stream, and here we go. Cool.
That's dope.
Good job.
3 in the queue are ugly. Oh no. All right. Welcome everyone to Actual Education Office Hours. My name is Dr. Gold, the stream that helps out math, homework, science homework, all sorts of fun stuff. Dream, how do you know everything? I don't know everything. I know a lot of, like, I would say middle school through college curriculum, like school things, just because I've taught it all so many times. And I continue to teach it pretty regularly. Some of my friends are jealous. They're like, man, I wish I remembered calculus. I say, well, yeah, I have to teach it literally every week. There's always someone asking a calculus question, so I never forget it. Use it or lose it type thing. All right. Let's go look at the queue. Let's see what we got. 3. The 3 in the queue are ugly. All 3 of these are ugly? I don't know. I don't think they're all ugly. Okay. All right. Well, let's spin the wheel. See whose question we're going to do.
Let's go gambling.
Moment to Shine, part 24. Okay, cool. Don't worry, Dream. You're at 80% chance for the next one. Okay. Let's see how bad this one is. I will put like a cap on the amount of time I'll spend. Like maximum 15-20 minutes. If I can't get it within 15 or 20 minutes, we're going to look at the solution and figure it out. Yeah, so the moment to shine is, his name is Kaushik Techno. He's always on our YouTube channel. Or she, sorry, I don't know what your gender is. I just assume it's he because, like, that's like the majority of what my metrics say my audience is. But Kaushik is is a really fun viewer from YouTube who is always kind of posting these, I would say like challenge questions. And I like that they're titled Your Moment to Shine. I think it's trying to like build confidence in that I can solve these really, sometimes they're really, really tricky puzzle math questions, almost like math competition questions. At the beginning, I loathed them. I really didn't like them because similar to competition questions, I just get upset when I can't do things. But over time, I've gotten better at them, and Kaushik has been good at, like, I guess, giving me questions that relate to things I've already learned. It's kind of fun, actually. I have like a teacher, basically. The bot is special needs. I put difficulty 5 out of 10, and it put it as 1 out of 10. Oh, really? All right, we'll take a look at it. Yes, Dream. I can ping you. Just make sure you show up. Make sure you show up, Dream. Okay, let's see. Jeff says there are 3 cases here. Either x is less than -1, x is in between -1 and 1, or x is greater than 1. I guess we're talking about this absolute value, right? Whenever you have absolute value questions, I mean, this is useful. Again, Dream, you should probably watch this. Even if it looks complicated and not related to what you're doing, it's a good refresher. I'm going to go over like some key concepts here. If you have, for instance, let's say the equation x minus 5 is equal to 6, right? Or let's make something even easier. Just say x minus 5 is equal to 3. Let me get like kind of chill. How you solve absolute value questions, a couple ways to do this. My preferred method is to write one version where we just remove the absolute value. Okay, so for instance, I could just say, okay, cool, x minus 5 is equal to 3. And then the other version I like to do is just multiply everything inside by -1. You can get the same effect by multiplying everything on the other side by -1, but sometimes there's like other stuff here and like people forget. So, or they forget to put everything on one side. So for instance, there might be like a 5 plus here and like a 3 times, and they forget like, oh, I need everything to be negative. So what I like to do is just take whatever's inside here and multiply it all by -1. So in that case, it would be -x plus 5 is equal to 3. Another trick is anytime you have like something minus something and you multiply by -1, you can just swap the order of this. So this is the same thing as just saying 5 minus x is equal to 3. And then you solve both of these, okay? So this one's pretty easy. You solve this and you say, oh, hey, okay, x minus 5 is equal to 3. Just add 5 on both sides. And you just get x is equal to 8, right? That's beautiful. And then this one, I'm like, okay, well, 5 minus x is equal to 3. I mean, it's pretty easy to see, right? 5 minus 2 would be equal to 3. So you can say x equal to 2. And there you go. You have 2 solutions, right? You have either x equals 8 or x equals 2. And that was like 2 different cases. So there was the case that x was greater than 5, right? If x was greater than 5, then this is the way you would do it. And then if x was less than 5, you would have to do this method. Curious why Jeff says there's 3 cases. I guess it's because of the x squared, right? So in my mind, so this is kind of like just like a little example of how this would work. Yeah, so in my mind, if we're considering, let's say like x squared minus 1 is equal to, I don't know, like let's say like something nice. Let's say 8. Okay, cool. I was like doing like little test cases to try to explain the math of what's going on. I would see like 2 things here, right? So I either have the case that this whole thing is x squared minus 1 is equal to 8, or the case where negative x squared plus 1 is equal to 8. So yeah, you can have either, okay, I think I see what you're saying here, Jeff. You can have like x squared is greater than 1, right? That's what we're saying here, right? X squared is greater than 1. Or x squared is less than 1. Okay. But then we also need to consider, like, -1 is also a thing just because of x. I see. Because even this in itself is a thing, right? If x squared is greater than 1, that actually splits out to two cases as well. That could be x is less than -1, or x is greater than 1. And then this could be x is less than 1, or x is greater than -1. Right, exactly. Yeah, that's the problem with like x squared. It's almost like another absolute value. Like squaring something is kind of like absolute valuing it because you're enforcing it to be positive again. Yeah. Oh, and x is greater than or equal to 0. Not all values less than 1. Wait, which where? Are you saying here? But if x is greater than, or sorry, not, or I would say like and, sorry. There you go. Yeah, sorry. Yeah, not the or. I made a mistake there. Okay. So cool. I see. So we have 3 cases, right? Yeah. You either have x is less than -1, x is greater than 1, or this case, right? This is or, because you can have it either be to the left of -1 or to the right of +1. For this to be true, it has to be in between 1 and -1. So this is like our 3rd case. Okay, cool. All right. I'm curious. Number of real roots. I feel like I still want to solve it this same way, maybe. And then we'll just kind of see what happens, right? I feel like I can do that. Let's just do it. Okay, let's do it this way. Okay, to be pedantic, you have to handle x is equal to plus or minus 1 in one of the cases. Ah, okay. I see. Maybe we just handle it in this one. So let's just try removing the square root, seeing removing the absolute value and see what we get. So I get 3x squared minus, we're just going to get rid of this absolute value. So that's going to be 4x squared plus 4 plus x minus 1.
I think there's actually a faster way without considering cases.
Okay, without considering the 2 cases?
Yeah, so if you square it, right, we can get rid of the absolute, just square everything. You can get rid of the absolute value, and then you can apply the fundamental theorem of algebra and just check discriminants to see if they're going to be all real.
You want to square the whole expression? You want to square this whole thing?
Yeah.
That's messy.
Yeah, you square.
Bullshit, not
I mean,
good.
yeah, it's messy, but if you square it, you get rid of that. What's it called?
Wait, you're saying like move this over, move this over, move this over.
Yeah, move everything over and then
except for
square
this,
both sides,
and then square both sides.
And then you can get rid of the what's it called?
Does that work?
Absolute value.
Sorry, yeah. One sec. If I did, for instance, like x plus 3 was equal to 6, you're saying I can just like square both sides? What? So x plus 3 squared is equal to 36?
Mm-hmm.
I guess that creates like 2, right? Because then you say, yeah, cool. So x plus 3 is equal to plus or minus 6, which is the same thing you're doing. Let's see. Wouldn't it be easier to split into 2 equations, one leaving x squared minus 1 as is, and the other one turning to 1 minus x squared? That's what I think. Let's see. We'll try both methods, because I think that's what I'm doing, right? Here I'm just leaving it, and then yeah, that was kind of my original plan. But let's see if, I mean, maybe Bressa goes on to something. And then this one I would say, okay, this is 3x squared, and then this is minus, so this is plus 4x squared minus 4 plus x minus 1 is equal to 0. And I'm curious if we have any like repeated roots. That's going to be the cool thing here. Okay, let's see. And then yeah, just check discriminants, right? So this is negative x squared plus x plus 3 is equal to 0. Cool. That's going to have, I think, 2 real roots. And then this one would be 7x squared. Let's use same color. So this one, we got rid of these things. This one, we multiplied everything by -1. Okay, and then this got me 7x squared plus x minus 5 is equal to 0. This one I don't think will have roots. Let's just check the discriminant. So that's b squared minus 4ac. And so that's going to get me 1 minus... Oh, actually, no, so we'll be okay. Because there's a minus sign here. That helps. Okay, so plus... What is that? 28 times 5 plus 140? That's kind of high, actually. Yeah. Okay, cool. So this is positive, so this means 2 real roots. So look at this one. B squared minus 4ac, so that's 1 plus 4 times 3. 4ac, cool. That's 13. That's also 2 real roots. Wow. Okay. At this point, I'm tempted to say that I don't think they share roots. Oh, interesting. Okay, wait. So Jeff brings up a good point. He says, but the roots only count if x is between -1 and this is another key thing. So even though well, I get that you have to get the roots and then you plug them back in to make sure they make sense, but yeah, we could just go like find them. It's kind of annoying though, right? I don't think these are really nice things.
I just use the quadratic formula, and then you can pretty
Yeah, whatever. Just use a quadratic, sure. Remember, absolute value of x is only equal to x when x is greater than or equal to 0. Correct. Okay. Absolute value of x is only x when x is greater than 0. So that's when x squared minus 1 is greater than 0. So x squared is greater than 1. Oh, I see. Okay. All right, let's see what we got. So for this one, x equals negative b plus or minus the square root of b squared. Oh, we already have the discriminant. Minus 4ac. All over negative 2. Okay. Wait. For this one, I think we were okay, right? Saying e has to be less than -1 or greater than 1. I don't know. What's the square root of 13? It's probably around 4. So, is -1 minus 4 over -2? That's going to be 5/2. Cool. That's greater than 1, so we're good. And then if I add them, -1 plus 4 is 3. 3 over -2 is -1.5. That's also less than -1. So I think these two are okay. I think we're allowed to say these two are okay. Let's check this one. This one's not as nice. So x equals negative b plus or minus the square root of 141. Oh, wait, isn't this 12? That's nice. Love that.
No, 144 is 12.
Oh, damn it!
Oh no.
Man, I thought 141 was something cool. All right, we're just gonna say it's
No,
around 12.
it's 121. 121's 11.
Oh, 121 is 11 squared. That's what I was thinking about. Oh, Jesus. Yeah, my brain's gone.
Oh no.
Okay. And then this is all over 14. Okay. This one we said had to be between 1 and -1. I don't think either of these are going to... Well, actually, they will. Actually, I take that back. Because if I add that, I get 11 over 144. This is definitely between... I mean, this is like basically like 0.1. And then if I subtract them, I get -13 over 144, which is basically like, yeah, negative point, I don't know, like 1, 2 or something. Okay, cool. So actually these satisfy.
Oh, yeah.
I think there's 4. I could technically plug them back in. I just don't really want to do that.
Oh my god. Bro.
Sounds like it would suck.
Hell no, man.
Okay.
What the fuck, man?
Let's assume there's 4 real roots. I'm curious. Let's go ask the chatter of GPTs, the chatter of PTs. Let's see what they want to say. Or Kaushik, if you're watching, you want to let me know. So I don't have to like waste water bottles on this. Desmos it. I get that is one way to do it. That would use less water bottles. Okay, 4 total roots. Oh, thank you, Dr. Aura. I'm always learning, you know. Might I suggest one Aura way of doing it? Just take the absolute value function from the left side to the right side and graph both. Yeah, of course. I mean, that's the easy way to do it. I mean, if you want to solve any like equation for roots, you just graph it, yeah. But I think this was cool doing it this way as well. Okay, cool. 4 roots. I think we're correct. Great. Awesome. Good.
That's dope.
That was a very manageable question. Wow. Kaushik, you gave me a good one. Correcto mundo. Yeah, we did it. Love it. Okay, cool. Good to check everything, though. Okay, so this was Kaushik. Only took 17 minutes, not bad. Cool. Alright. Let's go see. Dream, maybe your question's gonna get picked. Although, wait, what breasticles? What? How is yours actually a 1 out of 2?
I told it. I said
Finish
difficulty
the question
out
from
of
last
10,
time.
and I thought it would actually like
Oh,
put in the
no.
difficulty because like
Oh man, what did it say? What did it say on the thing? By the way, what does it say?
it just says like other
Continuations, homework prompt,
continuations.
clear short instruction with no actual problem. Okay, all right, we'll do it. If yours gets picked, I'll just re-roll again. It's okay. I don't want Dream to be like waiting forever. All right, let's try to spin.
Let's go gambling.
Yeah, I'm not. Trying to slow it down.
Oh
All right, it's okay. I'll skip on this one. Here, just put it in again or something, or can you just drop the same screenshot in? Just drop the same screenshot in. Just like change it slightly.
Yeah. I'll try to.
Yeah. Okay. All right. Here, you know what, Dream? Since we just did one of Kaushik's questions, I'll manually just bump yours and do yours right now. Cool. All right, let's do it. Let's do it, Dream. Good. Dream is here. Wait, give me 1 sec. BRB. Wait, what? Dog, what? I said we were gonna do your question right now. This is a good one, actually. I like this. Good question, Dream. I can always tell when students are going back to school because my YouTube channel starts getting all these comments about people finding my content and being like, oh man, like, why do you do this? Why do you do that? It's if I go to my studio controller community, there's always great comments. Someone's like, here, why do we put a dot below t equals 5? Can't we just connect it straight to t equals 11? They're like, wait a minute. Wait, is it because it's it's constant? Yeah, there you go. People like you make the world a better place. Aw. Sorry, I haven't gone through these comments. I've been kind of busy. Yeah, it's here. Someone's asking about NO2 without charge. Yeah. Okay. Cool. Cool. I need to go through and answer these comments for a bit. Someone said W content little bro. Dude, wow. Little bro. Okay, Dream, what's up? Are you here, Dream? You here, Dream? You hit /BRB, but...
Let's go gambling.
You should write out the 9th derivative of angular velocity using Newton's dot notation.
The 9th derivative?
Yeah, it makes a funny shape.
Okay, alright. Oh, wait, Dream says they're back. But, wait, the 9th derivative of velocity, sorry?
Of angular velocity.
Angular velocity.
So the omega.
And then you want 9 dots? Oh, I know where this is going.
Oh no.
Almost got me there. Almost got me, dude.
Yeah,
Dude,
that's on
a
an
good
Instagram post. They were
That's a
like,
great
this is
one,
why
actually.
Newton shows dot notation.
That's a great one, dude. Oh my god. Okay, Dream, listen up, pay attention, because I'm gonna ask you a follow-up question about this. So if anything doesn't make sense, make sure you ask in the chat. Okay. All right. The amount of pollution in a certain lake is P of T is equal to T to the 1/4 plus 3 to the 3rd, where T is measured in years and P is measured in parts per million. At what rate is the amount of pollution changing after 16 years? Okay, this is very important. Okay. So they're saying rate. So the key thing about rate, right? Rate is always a change in amount divided by a change in time. That's what like a rate is. Like it's how much stuff is changing divided by like how much time does it take for that amount to change. And in calculus, we can represent rate or instantaneous rate as a derivative. You put time above, not under. Yeah, no, time is definitely under. Think about it this way. All right, let's say, for instance, I don't know. What do you like to do, Dream? Do you have like any hobbies that you really like? You like basketball? You like Pokemon cards? What do you like to do? You like to draw. Okay. All right, let's say like, and just games. Okay, well, drawing's still cool. Let's say like you have one of those like color by number books. You know what I'm talking about? Ever seen these before? Yeah, these are super cool, right? They give you like something here, and it's just like every color, every number you got to fill with a certain color. Okay, so let's say, for instance, you're doing a color by numbers thing, and you want to figure out how long it takes for you to like do this entire painting thing, or how fast you're doing what the let's graph, for instance, versus time. We're gonna graph the number of colors filled, okay? Because usually what you do, right, is you're like, okay, I have my red pen, and red pen is number 2, so I need to go find all the number 2s. And then you get your green pen, you're like, okay, now I gotta go figure out what all the number, I don't know, 7s are or something. And let's say, for instance, we're gonna time ourselves as we're doing this, okay? So let's come up with like a little like grid line here. So let's say after, and let's put this in like minutes, okay? So we're looking at number of colors based on the time. Let's say that after 10 minutes, you've graphed, so at 0 minutes, right? You've graphed 0 colors because you haven't started yet. Let's say after 10 minutes, you've graphed 1 color. And then it takes you a little bit longer. Let's say at 20 minutes of time, now you've graphed 3 numbers. Or no, let's do it in order. Okay, let's say like 2 have been graphed at 20 minutes. And then let's say after 25 minutes total, now you've graphed 3. And then let's say after another 5 minutes, now you've graphed 4. But then let's say it takes another 10 minutes to get up to 5. Right? And then let's put one little last piece of time here. Let's put 50 minutes. And then let's say after another 5 minutes, you graph 6. Okay. So as something that's like
be 45.
Yes, correct. Thank you. Sorry. Let's make this 45. Thank you. Good catch. Time always goes. Yes, time will almost always go on the x-axis for the majority of things you work with. Yes. Okay. So, for instance, right, this could be a graph showing the number of colors that you finished after a certain amount of time. You might notice something here, right? That the rate at which you're coloring or filling the colors is changing, right? So, for instance, from 0 to 10 minutes, you've only filled in like one color in 10 minutes. That's kind of slow, right? Whereas, for instance, for this little 10-minute window here, right? Let's say from here to here, you've hit 3 colors. And that could be described as like the rate at which you're filling the colors. Is it like an average? It's kind of like an average, but it's how much is it changing over time. So, for instance, for this section right here, let's just say just going from here to here, the rate at which you're filling colors, right? This would be 1 color in 10 minutes, okay? And that's a rate. So between 0 and 10 minutes, you only filled in 1 color, so you were working at a rate of 1 color every 10 minutes. So that means if you stayed at this rate, then after another 10 minutes, you should fill in 1 more color. And actually, that would be the same here. Sorry, let's make this graph look like a little bit better. It's because I'm not doing everything like perfectly on a grid. Yeah, this should be the same. And in fact, you do, right? Look between 10 minutes and 20 minutes. That's another 10 minutes that you did 1 color, right? And this is also 1 color every 10 minutes. Yeah, the numbers will be sometimes weird. It's okay. For instance, here they will, all right? So when we look in between 20 minutes and 30 minutes, right? That's another 10-minute section, but now you've done 3 colors. So here the rate, which again is the change of the amount of stuff you did over the amount of time it took. That was 3 colors in 10 minutes, okay? This is a faster rate, because now, if you would expect after another 10 minutes, you should have another 3 colors that have been done. But you don't, right? The rate actually slows down because it takes another 10 minutes to just do 1 color. 2, no, not 3. Well, 2, 3, 4.
Yeah, because we already.
Oh, okay.
colored
Sorry.
At
Sorry.
20 and then
Sorry. Thank you.
redone.
Thank you. Yeah. Yeah, we've already colored this one. Sorry. Yes. Thank you. Yeah, Narowski. Yeah. Yes, there are different rates at each period. Exactly right. Yeah. So notice that the rate at which you're filling things in is changing over time. So we could figure out what's called like an average rate, which that would be this line right here. This line right here, this would be the average rate, which would be equal to how many colors did you do, right? 6 colors over 45 minutes. So that's the average amount of time. But notice, if you look at what's called like the instantaneous rate, that changes. So for instance, this rate is different than this rate, which is different than this rate, which is different than this rate. Yeah. Well, okay, but this question here has nothing to do with that. We could graph this if we wanted to. I just wanted to make sure you understood what like rate means. 'Cause you were saying like I think I should put time on the top, and I'm like, no, No, we gotta understand time is almost always on the bottom when it comes to the rate. You understand? Okay, cool. Fine. Okay. So this is like a simple way to figure out rates of things that are changing. If we want to figure out exactly at a single instance what the rate of something is that is changing, what we need to do is called use a derivative. You can start to understand this for what's called like the limit definition of a derivative, which I've done a video on it. Let me go look at it real quick. This is a little bit advanced. But again, if you're already doing derivatives, I feel like you should know what the limit definition of a derivative is. You think you can do it without my help? Well, I'm not sure, because I don't think you knew what rate was. But can you send me the solutions?
Oh, no.
No! Oh, Jesus.
Let's consider a function f and a...
Okay, anyways, alright. So, anyways. This is a video I've created. You should watch this at some point. It explains, like, how instantaneous rate of change works. And it's because you're taking the average rate of change between 2 points, and then you're just putting those points really, really close to each other. I think I have this where I put them closer together. Yeah. There you go. See? As the points get closer and closer to each other, then you get what's called like the instantaneous rate of change, which is the tangent. Yeah, okay. All right. So, yeah, this is rate of change in a nutshell. Just kind of real basic. And then what we could maybe call this like instantaneous rate of change. Ish. Okay. Here's the key thing. Instantaneous rate of change is also equal to the derivative of a function. So, in this case, they said P of t was equal to t to the 1/4 plus 3 all to the 3rd. And they wanted to know at what rate is the amount changing after 16 years. So they want to know what is dp dt at t is equal to 16. This is where, Dream, this is a little bit more complicated than, this is why I get kind of worried if you're asking this question about like, wait, how do I calculate rate? But now I have to teach you what like the chain rule is for like calculus. It's quite a jump, if that makes any sense. Do you know what a derivative is, Dream, by the way? You were only confused with the rate? Okay. Do you know how to take the derivative of this then? Mostly? Okay, then how do you do it? Show me how. I want you to show me how would you take the derivative of this? How do you show me? Oh, just type. How do you think you do this? You should be able to describe what you would do with typing. I guarantee a lot of people in this chat could like type what the first step is to do. Give me 1 sec. Okay. This is usually where it's like, oh, let me go ask ChatGPT.
Oh, no.
But Dream, is not the point. I want you to learn. I want you to actually do things. You're not searching it up. Don't worry. Okay, I trust you. This is why, like, I say, like, online education is going to get really bad. AI is just going to make this absolutely awful, trying to, like, teach kids. Because at least, like, when I have someone in person, I can kind of, like, read their body language and understand if they're actually getting it, or if they're just trying to, like, hey, man, don't bother me. just want to like get through this class. I'd be like, no, you gotta like poke at people and be like, why do, until you get this, we're not moving forward. But with the advent of online stuff and AI, any kid can just fake it. Just fake that they know it. So it gets like exceptionally difficult as a teacher to, I guess, do like little wellness checks on people's education. Like, are you learning things? Oh, Bella, just looking with you. Miss you all. I hope you're feeling better, Bella. I know Bella's going through some health stuff. I'm sorry about that. The misuse of technology is horrible. Exactly. I would agree. Okay, Dream. It's been more than 1 second. So, I'll show you. Okay. So, if I want to take the derivative of something, and that something is going all the way up to the third power, okay? This is a case of where what we're going to do is we're going to pretend that whatever's in here is just a box. I'm kind of struggling. That's okay. It's okay. I'm glad you're admitting that you're struggling. That's the point. First of all, this would be my first question, Dream. Is this actually a question that you have to do? Like, or did you just Google something on the internet and be like, let's dump it? Because that doesn't help you. I want to help you with questions that you actually have to do in your class. It's a homework question I don't get. That's perfect. Okay. All right. So this is a homework question about derivatives. So the first question would be, do you know how to take a derivative? Like, for instance, Dream, if sometimes ChatGPT gives me bullshit, that's correct. I mean, that does happen. I mean, I don't think it would give you bullshit with this one. Here we go. Let's roll it way back. Let's say like here's a derivative question. Just I want to make sure you at least know this. Let's say that y is equal to 4x to the third. Could you tell me what dy dx is? I have a lot of patience in my life. Don't worry. Now you're asking him like a real teacher. Yes. I mean, I am a real teacher. You're right, Couchik. Yeah. I mean, this is what education is. Exactly, JC. I know. Oh, Narosky says, I heard through to differentiate. I did it wrong at first. Yeah. I make mistakes too. Like, bro, like even earlier, like I didn't understand like what going from here to here was. I understand that's a change of 2, not a change of 3.
Or the square root of 141.
Yeah, or that the square root of 141 is not 12.
Bruh.
It's alright. Come on, Dream. We're gonna help you, dude. Very basic. What's the derivative of 4x to the third? Dream says it's 3 times 2. Close. 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 Okay. You're getting close, Dream. So whenever you have like just something to an exponent, what happens is you take whatever the exponent is here and you bring it out front and you multiply everything. So this would be 3 times.
I think he tried to type that. I think he meant to say 4 times 3x squared.
Oh, okay.
But I think.
Well, no, he forgot the 3. He forgot the 3 as well.
No, I think the x. I don't think that was multiplication. I think that was meant to be like 4 times
4.
3 times.
3 multiply power of 2.
Maybe not. I was trying to give you.
No, I don't think so.
Bruh.
Okay, here's what happens, dude. All right, the 3 comes out front. Okay, it's gonna multiply everything here. Okay, but now instead of it being x to the third, it's gonna be x squared. That's what happens. Okay. Okay. So your final answer would end up being 12x squared. That's called the power rule. That's a very like important basic thing we need to learn in calculus. Like this question, doing it fully requires the chain rule and the power rule. So I want to make sure you understand the power rule first. Do you see how the x like still needs to stay there? X doesn't just disappear. I mean, without basic knowledge of derivatives, how can someone have this question? Was it meant to be solved arithmetically or what? Dream says I'm super lost. Okay. All right. That's okay. This reminds me of this like news article. It's in Forbes actually right now. It's the epidemic that's happening. We're having like a very serious reckoning point now with I don't mean to shame you here, Dream, because it's not your fault. But there's a Forbes article that came out today. It says when straight A math students aren't ready for college math. And yes, it is a big problem. A lot of kids who like seemingly have straight A's in math and they're going into college can't do like basic high school math. It's because there's a lot of like grade inflation. It's also because they got rid of the SAT. So the SAT no longer like gatekeeps and says like, hey, if you can't do basic things, like you're not gonna go to college. Or I don't know. It's just, maybe it's this like No Child Left Behind thing that happened as well. But education's pretty fucked, man. How hard is college? It doesn't have to be hard, Dream. This is a college level question, by the way. You know, so if you're in high school, like, congrats, you're doing something a little bit more advanced. But I'm curious what your teacher's teaching you. Or like, I always get curious, like, what happens in class? Some students say they just go into class and their teacher just puts on a YouTube video and just says like, hey, watch this, guys. I'm just like, what?
Oh no.
What's happening? In theory, you could multiply out the cube and just use the power rule, but don't. Yeah, that would be a nightmare, dude. Okay. Here. I will spend like another 5 minutes on the stream, but then I gotta like kind of move forward on things. Let's try to at least make sure you understand how derivatives work. Correct. No, you're not wasting my time, but no, and again, 100%, you're not wasting my time. That's the whole point of this stream, is to like help people that don't know things. But I think we really want to like get down to the core of like, you know, let's make sure you understand the fundamental basic stuff first, and then like we can go to the more advanced things. Showing you how to do this question, but you don't know how to do a derivative is useless.
Emotional, damn it!
Because math is like building blocks. We have to have a foundation until we can start building like the rafters and like the roof, like, or even the sidewalls, or I don't know, like the plumbing. First of all, are you in a calculus class, Dream? Is this a calculus class? This seems like a calculus question you've been given. So you're struggling to derivative. Okay, that's okay. All right, so let's do, here, I'll do a little like quick little lesson on like how you take a derivative. Okay, like really simple derivatives, right? Simple derivatives. It's okay. There you go, Jeff. Okay, here's the simple way to do derivatives. Okay, if you ever have something, a function, right, where you have y is equal to, and let's just say it's x to some power. Okay, this is like a power. Will there be office hours tomorrow? I think there will be, yeah. The derivative of y, and we say like with respect to x, Don't worry about the with respect to x. That can be confusing sometimes. Which is the same thing as saying dy dx, which is also the same thing as like y prime. This is another way to write it. What happens is you end up taking whatever this power is, okay? And you're going to multiply it out front. So this number here is going to come out front. To multiply by this. Or you could like do this, I guess, maybe. And then whatever this number is going to drop down by 1. And so your final answer is going to be whatever like ... is times x. And then we would say to whatever that number was, ... and then like minus 1. Does that make sense? This is called the power rule, Dream. The exponent comes up front. Yes, yeah. Whatever the exponent is, it multiplies out front. Yeah. And then it subtracts by 1. Okay? So here's an example. Right? Let's say, for instance, I had x... Let's say I had, like, y was equal to x to the 5th. What would y prime be? What would the derivative of this be, Dream? Correct, Kaushik. Yeah, I hope in some cases not. Okay. So let's remember Dream, right? What do we do here? How would I apply it to this? It's one thing to learn a concept. You really don't learn things until you do things. So let's try to do this one. Yes. Yes. It would be 5x to the 4th, right? You see how I took this? I brought it out front. I dropped the exponent by 1. Yeah, look at that. Yay.
Good job.
No more tears, dude. It's okay. No tears. Okay, let's do one more. Let's say that y was equal to 6x to the 3rd. What would y prime be equal to? Close. So you said 18x. So I agree. The 3 would multiply by the 6. That would be 18. 18x squared. Good. Okay, nice. Great. Good job, Dream. I'm happy. You learned something today. Yes. Good, Dream. There you go. Yeah, use the emoji. Cool. All right. Yes, in terms of like doing your actual question, maybe come back tomorrow for that, because then I got to teach you the chain rule, and I just wanted to make sure you learned derivatives today. Math is killing me. Well, yeah, come to the streams. Let's help you, dude. Yeah, you don't want to get left behind. Math. If you don't understand core things in math, it becomes almost impossible to learn the things later down the road. So, today, yeah, I don't want to do too much in one day. So, I'm glad that you brought this question and we're like, we figured out, wait a minute, let's make sure you understand how rates work. But then we also said, okay, well, in order to do this, we need to take a derivative, but we need to make sure you know how to do derivatives. So, we did the power rule for derivatives first. So, the next thing we'll do will be the chain rule for derivatives. But it's worthless for me to try to teach you the chain rule if you don't understand the power rule. So, yeah, come on tomorrow. Congrats, you get a bond coin. I'll get you your gift card because, yeah, that was the requirement. You have to ask at least one question. I wanted it to be a good question, and I wanted you to learn something from the question. So, I appreciate that. Good job. Okay. Jeff, and then we integrate square roots. Yeah, my bad. I genuinely have to pay attention. Correct. Yes, it's okay. I'm glad you're realizing it. You know, it's better to realize it at some point than to have never realized it. That, yes, in order to learn, you need to pay attention. And we try to make it easier for people to pay attention here on the stream because we do it in a format that you're used to, like, spending a lot of time on, right? You guys are always on your phones. You're always on YouTube. You're always on TikTok. So we try to do the education on those same places that you do pay attention to. I know you guys pay attention to TikTok. I sometimes don't pay attention yeah, you doom scroll. Cool. Yeah, dude, everybody doom scrolls. It's okay. The point is, like, we want you to like scroll on this and then like pay attention to this, and this will help you in math. It's totally okay to say you don't pay attention in class. I would blank out in class all the time. I still do. If I go to like lectures or talks, I'll totally like zone out sometimes. It's fine. It's a natural part of human life. But you need to then like go back and remedy that by actually learning the material at some point, which we can do here. Review. There you go. Yeah, cool. Okay. Let's see what we got. We got more breasticles 510 difficulty, dude.
It didn't do like the parentheses or the division
You too.
symbol. It just cut out all of the.
Oh, okay, whatever. You'll probably win on this one. Let's see.
Let's go
I
gambling!
was trying to keep
Actually,
it like 50-50.
Kind of 50-50 though. Yeah, you did it. You got it. All right. The problem from last time. Oh, also, I should do one of these. We have a really good one here. I'm going to submit this one for Litbox. 1 sec. Okay. 1 sec. We're allowed to cheat like that? No, but breasticles is okay.
I tried to make it like pick up that the difficulty was a 5 out of 10, and it didn't work. It was more of a test.
Yeah. It didn't really work though, yeah. Dude, why can't I... Oh my god. Why is my keyboard not working? Excuse me. Hello. That works. Clicking on Discord doesn't work anymore? Man. Oh my god. 1 sec. That is super strange. I literally can't click on Discord. Okay, 1 sec. I'm gonna kill Discord. Then we'll be back. I still can't click on Discord. God damn it, 1 sec. The Haversign method? Okay, there we go. Back. Share the screen. I wanted to know why I couldn't do this. There we go. Upload that. Which one was yours, Brescos, by the way? Sorry. Was it the Poisson one? Prove the was it this one, the Laplace equation thing? I think I might have cleared the board from last time. Let me see. Oh, it was this, right? Oh, why can I not hear you now, dude? What the hell? Your thing is green, but I can't hear you. Oh dear. No. Try unmuting yourself again. No, still can't hear you. All right, one sec. Let me leave the stage. Let me speak on the stage again. No. Let me disconnect. Oh, dude. It's technical difficulties today, dude. Okay. Now try saying things, Breskles.
Yellow.
There we go. Oh my god. I don't know. Mercury in retrograde today or something? Like, what's going on?
Who knows?
All right. Okay. We did.
I think we found.
We found part
data. We need to find R.
Oh, okay. We did, yeah, with Legendra's stuff, we did this. We found big theta. Okay, great. So now we need to go find big R. Is this from this one?
Mm-hmm.
Okay.
Yeah.
Let me remember, like, what a Legendre thing looks like, because maybe I can, like, understand, like, where I'm trying to make it, like, look like
Oh,
this.
so the big R actually isn't a Legendre.
Oh, it's not? Okay.
Yeah, this
Okay.
one's just, we'll just do the chain rule and solve normally. It's not that bad of a
Just do the chain rule, he says.
either solve. Or not the chain rule, I meant product rule.
Okay. All right. I can remember like what R prime is. R prime is. Oh, big R prime is
The
derivative of big R with respect to little r.
Yeah.
Got you. But then I also have another like derivative here. So you think is it a product rule between these two? Is that what you're
Yeah,
saying?
you'll want to do the product rule.
All right, let's do the product rule. So that's going to be 2r dr, which is just 1, right?
Mm-hmm.
Times r prime. And then plus r squared. I want to say r double prime then, right? Big R double prime?
Yep.
Good.
Mhm.
And then this is all times 1 over big R. And this is equal to L times L plus 1. Okay, the weird thing is that I have this and this. Because this is technically partial R, partial X. Or partial R, partial little r. But I have little r there as well.
Yeah, so what you'll want to do is first you'll want to move over the big R to the other side.
I agree with that.
And then this is what's going to be called a Cauchy equation.
A Cauchy equation. Ooh, okay.
And so we're going to start by just assuming that it's of the form R to the L.
R to the L.
Yeah, little r to the L.
Okay, so we're going to say that R is of the form. Of little r to the L?
Yep.
Okay. Okay, so
Or
then...
I guess R to the N. I realized we already use an L. It's not the same L.
Oh, it's not the same L as this?
Yeah, it's not necessarily the same L.
Okay. So then R prime would be equal to N R to the N minus 1, right?
Mhm.
And R double prime would equal to N minus 1 R to the N minus 2, yeah?
Yep.
Okay, so let's see what that does. So I'm going to have 2R times this plus R squared times this. Sorry, then all of this is equal to big R L plus 1.
And we also
Yeah.
know what big R is. We know that that's
Oh,
also
yeah,
R
big
to the
R's
N.
R to the N. Yeah, hell yeah, dude. Okay, fine. Okay. Now, why did we do that? Is this just like a standard technique in DiffEq?
So, yeah, just because we recognize, right, that that's a Cauchy equation, we start with that assumption. And then you'll notice that, right, on our r to the n minus 1, it's multiplied by another r, so that becomes r to the n. And then with our r to the n minus 2, it's multiplied by an r squared. So that becomes r to the n, and then we can cancel all of our r to the n.
Oh, this is so cool. I see. I understand why. Okay, so the first derivative is attached to an r. The second derivative is attached to an r squared. So you're always going to eliminate that. Oh. That's cool. Okay. Right. Okay. Because, yeah, let me explain to people why that is. So r times r to the n minus 1 is equal to r to the n minus 1 plus 1, which is just equal to r to the n. That's where this comes from. That's cool.
Exactly.
Okay, so 2n to the... I feel like I've seen this before. And then this is going to be n...
pretty standard.
N minus 1 r to the n is equal to r to the n l times l plus 1. And then, yeah, bingo. All these are going to go away. All these r to the n's. Get out of here. Cool. Love that. That's dope. All right, so 2n is 2n plus n times n minus 1 is equal to l times l minus 1. Or l plus 1, sorry.
Yep.
Is this a quadratic I'm going to have to solve?
Yeah. Yeah, it'll turn out to be a quadratic you're going to solve.
Okay, so 2n plus n squared minus n is equal to l times l plus 1. So n squared plus n minus l times l plus 1 is equal to 0, right?
Yes. Yeah.
Cool. Do I use the quadratic equation?
You can factor it. It factors to n minus l and m plus l plus 1.
Sorry, what? This factors?
Mhm.
I don't believe you.
It does.
Well, one sec. X, so I would say that n equals negative b plus or minus the square root of b squared. So I'd say 1 plus l times l plus 1 all over 2. Oh, man. Yeah, what? Now this is going to be what? N minus, and then it would be negative 1 plus the square root of 1. This is a mess. How do you get this to factor into what that magic shit is that you said? What? Excuse me?
I want to say it's grouping. We'll just use grouping.
Just use grouping, he says. Okay. That's like completing the square, right? Ish.
You would basically say that n minus l and then n squared plus l squared plus 1. I forget exactly the method, but you just combine, take two terms, and then they multiply. It's been a long time since I've actually
Yeah, I just don't see it.
Explained how to use grouping.
Well, grouping is usually, that's what completing the square is you're kind of like, well, no, that's when you're, sorry, that's different. By grouping, usually you have 4 terms, and you're showing that they have like a common thing they both multiply by, which maybe we do have here. One sec, sorry. N squared plus n, and then I'd say minus l squared minus l is equal to 0.
Mm-hmm.
Okay, so maybe let's group this together. N squared minus l squared. And then this is also going to be plus n minus l, I guess, maybe. And then this is going to be, oh, I see. I got it. This is n plus l, n minus l, plus n minus l is equal to 0. Now this is the common factor. And we can pretend that there's a 1 out front here. So that tells me that n plus l plus 1 times n minus l is equal to 0. Uh-huh. Okay, cool. I got it. Yeah, I just needed to see that. I was like, yeah, grouping, you usually need 4 terms. Is what you need to do grouping. That's cool. All right. Okay. But my solution was that it's of the form r to the n. So that tells me that n is either equal to L or n is equal to negative L minus 1, I guess, right?
Yeah. Yeah, or you could just say negative L.
Or
Negative times the whole L plus
that
1.
makes more sense, yeah.
Mhm.
Or negative L plus 1, sorry. Okay, cool.
Yep.
So now we figured out what our solutions are, right? We say like, okay, well, so big
Almost.
R. Oh, almost?
So, yeah. So, I mean, we got that. It's just, what we need to consider is it wants the bounded solutions, right? Because if you think about what's going to happen when we go to 0, then the n is equal to negative times L plus 1. That's going to go to infinity, and it's going to become unbounded at 0. So we need to just eliminate that, just drop it out,
Interesting. It's
and
gonna
not
become
consider
unbounded.
that value.
Wait, sorry. Why is it going to become unbounded? Sorry.
Because if our solution at 0 is
What 0,
r
sorry?
to the when r goes to 0 at the very center of the sphere.
Okay. So when little r goes to 0, you're saying I need it to still be bounded, right? Oh, okay.
Yeah.
Okay. I see. Okay, I see. Because like, okay, so big R as a function of r would equal to was r to the n. Okay, so that would be like c1. I think you were saying r to the l, and then we would say like plus c2 r to the negative l plus 1. But then the issue is that, right? So at r equals 0, this is going to become c2, and it's going to be 1 over 0 to the whatever, right?
Yeah.
And then this would be a problem.
Yeah, because then it's no longer bounded.
Okay.
You can't do that. So,
Okay,
you just
only
don't
keep the
consider
first
it.
one. I feel like it's okay for things to be unbounded at the center. Like we do with like potential and stuff.
Yeah, it's technically like it's not like mathematically wrong. It's just it says find the bounded solution. So
Okay.
since
Okay,
it's
so
unbounded,
R of
it's
R
the
is equal
solution.
to some constant, probably, right? C1 R to the L.
Mhm.
Cool. Nice. And is that the bounded solution? Wait, but there's a boundary condition though we can use, right?
Yeah. So we want to just multiply them together and then apply the boundary condition.
This is the boundary condition, I think, right here, right? The
Yeah.
U1 theta. Okay. 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 So U of R comma theta was equal to R of R theta of theta, and that's equal to C1 R to the L, and then P sub L cosine theta.
Yes.
Interesting. Sorry, what is L?
L is an eigenvalue.
L is an eigenvalue.
So from the original like Sturm-Liouville problem, which was what
from
happened
this.
when we first separated it, we would call it equal to a negative lambda or a lambda, which is the eigenvalue.
Mm-hmm.
And from our Legendre polynomials, it just so happens that the only eigenvalues that can take are going to be L times L plus 1, where L is an integer value.
Okay. Right. So, so U of 1 comma theta, which should be
First,
equal
you're
to-
going to want to take the superposition of this.
What? Excuse me.
The
superposition.
superposition. So the sum from 0 to infinity. Right, because
Of all the L's. Of all the L's.
Yeah, because P sub L could be anything. Right?
Yeah, I was like, which L do we pick?
depending on what your L is.
Okay, and then well, C1's gonna stay, I guess, right?
Yeah, C1's gonna stay. Sometimes you might rewrite that as like just a CL, or I would rewrite it as a CL.
Does it depend on L?
Yeah, because that ends up being a Fourier coefficient. Is what we're gonna say.
I see. C is a series as well.
Yeah, because that's why it asks about the orthogonality, basically, it's just to show that like you can in fact create a Fourier series just using your Legendre polynomials.
Okay, so if u of 1 comma theta is equal to cosine squared theta, that puts some restrictions on things, right?
Mm-hmm.
Because that would be the sum from L equals 0 to infinity of C sub L 1 to the L. I don't really care about that, right?
Yep.
And then I would say P sub L cosine theta. So that means, dang, how is this whole series going to equal cosine squared theta?
Yeah, so let me send you the link for the Legendre polynomials. It's just on Wikipedia. They say it, but you'll want to write out the first couple Legendre polynomials for this, and then it'll.
Uh-oh. Oh dear. Where's my oh no? No.
Oh no.
It's not as bad as it sounds. You can write out like the first up to, I want to say 2.
Jesus, dude, what is this?
Where n equals 2.
What is this, dude? The first few Legendre polynomials are. Oh man.
Yes, you want to write out till n equals 2.
Okay. I think I can do that. Alright, we're going to say cosine squared theta is equal to C0. Oh, but P0 is equal to 1.
Mm-hmm.
And then we say cosine theta. Or actually...
no cosine theta.
Let's just leave it at the end, right? Yeah. Actually, could I just divide the cosine theta out? Let's just divide when the cosine theta is out, right?
I would wait a second.
I can't do that.
It'll make sense once you write it out.
Everything's being multiplied by theta, dude. Whatever, cosine theta. Okay, fine. All right. So that's C0 times 1. I'm going to say plus C1 times X plus C2 times 1/2 times 3x squared minus 1. And then we're going to say plus the summation from L equals 2 to infinity.
Yeah, so what we're going to do is we're going to call that all of those other coefficients are going to be 0 after the 3x squared minus 1.
Okay.
Because in this case, because we're saying that it's P sub n of x. In this case, our x is cosine of theta. So see how once we have that 3x squared minus 1, when we substitute in cosine of theta, we have a cosine squared of theta term, and then we can create solve for.
Sorry. Where is... Sorry. All right. P sub L... Oh, of x. Oh, sorry. This is P sub L of cosine theta?
No, that's of x. So in this case, our x is going to be cosine theta. Because P is just some function, right? And
but
so
it's P,
whatever we have inside of P.
It's P sub L of cosine theta, not times cosine theta? Is that what you're saying? Like when we were here?
of P sub L of cosine theta.
Oh, okay. Well, that's a big thing. Okay. All right, now, okay, that makes more sense to me. I thought it was P sub L and like L was just some shit, and then it was
I
times
see. No,
cosine
it's
theta.
P sub L times
of cosine theta. I think that makes sense because we did that up here. All right, we said x was equal to cosine theta. So instead of here of like P of x, it's P of cosine theta. Okay, I got you.
Mm-hmm.
I think I get it now. Okay. Great. And we're going to call all this 0, is what you're saying?
Yeah. Because see how once you substitute in that x is equal to cosine of theta, see how you have a
yeah, I got you. Got you. Yeah, all these will be 0 because I can't have any higher order powers of it. Got you. Okay,
Yeah,
cool.
Yeah, we don't want any higher order powers.
That's fine. Okay, this is making a little bit of sense. Okay. Do you want me to substitute an x equals cosine theta?
Yeah, I would substitute an x equals cosine
Okay.
theta.
All right, so
And
cosine
then
squared
we can just
theta
set up
is
a
equal to
Pretty simple system of
C0
equations for our constants.
plus C1 cosine theta plus C2. I'm going to say over 2. I'm going to say 3 cosine squared theta minus 1. Fascinating. Okay. And then we're just matching by grouping then, right?
Yeah.
Because this
We're
is
gonna
0
look at it like-
cosine theta, or it's 0 plus 0 cosine theta plus 1 cosine squared theta. So what things don't have cosine theta on them? So that C0 doesn't. Let me mark all the things. So this one don't, and this one don't. So C0 minus C2 over 2. That has to be equal to 0. Okay. Alright, what do we got for cosine theta? Cosine theta terms, I got C1, that's it. So 0 is equal to C1. Beautiful. Cosine squared theta, we have this. So I have 3/2 C2 is equal to 1. Cool. Yeah, and that's just the systems of equations. Because this tells me right way. C2 equals 2/3. Beautiful. Plug that in. And I get that C0 minus minus 1/3 is equal to 0.
Yep.
So C0 is equal to 1/3. So then, cool. Okay. So this, so there. So it's no longer a series, and it's just equal to C0 is 1/3. Okay, so it was 1/3. There is no C1. Actually, let me just write it, sorry. So it's 1/3 plus 2/3. Oh, but 2/3 times a half. So it's just 1/3.
Yeah,
Plus
so r
1/3.
squared over 3.
Oh yeah, wait. Where the fuck did the r squared go? Sorry. Oh.
No, yeah, because we plugged in our boundary conditions.
And then this is right, r to the 3rd. And then cosine squared theta. Yeah.
3 cosine squared theta minus 1.
Yes, forgot about that one. Right, one sec. Okay, 2/3 gets multiplied there. Right, there's a 1/3 from that. Okay, got it. So 3 cosine squared theta minus 1. Yeah.
And then r squared, not r cubed.
Oh man, was this not? Oh, it was C2. Yes.
Yeah,
Okay.
yeah.
Okay, cool. So there we did, right?
Yep.
Wow. Okay, very cool. That's not so bad.
Yeah, the second, once you get past like the Legendre equation, it's not that bad.
All right, let's maybe do the Legendre differential equation part. Let's do this part next time.
Yeah, I can hold up.
Nice. This was cool. I like that we're getting further. All right. This one is done. This was Brescals. Ooh, I see Naroski, you submitted one. Thank you, Naroski's. Naroski probably got a fun one. All right. We're getting closer with this Legendre stuff. It's actually quite interesting. Let me Here, let me do lit boxes real quick because they asked this question over the weekend and I didn't do it. And then Naroski will probably do yours, and then if I have more time, I'll do more of Kaushik Techno teaching me how to do things. But we'll for sure do Naroski's after this one. I have no clue what Naroski's question is, but I do want it. All right, let's see. Someone did ask this. Use analytic methods to determine the following limit. Enter do not exist if the limit fails to exist, except in the case of an infinite limit. If an infinite limit exists, then enter infinity or minus infinity as appropriate. Tangent of 3x over an x is... So I think this is... So when they say analytic methods, am I allowed to use like the identity stuff? Like the trig limit identities? I don't know. Which one is it? Where's the tangent one? Oh, I need like tangent of x over x or something. Yeah, this is the one I want. I wonder if this is legal. Because in this case, this becomes actually kind of a pretty simple question, right? Like, let me see actually what the student said on this one. Okay, you know the identity, but I forgot how to do some of the algebra. That's okay. All right, let's just show the algebra. The algebra's not hard, actually. So we could do it the way where they just multiply top and bottom by a thing. Or we could do the U sub version. I like the U sub version, but some people don't. Okay. This is what I like to do. I like to say, let 3x equal u. So x is equal to u over 3. And then you can say, and as x approaches 0, so does 3x, which approaches 0, so u approaches 0. Once you know that, this is pretty chill. Because now, this becomes the limit as... I know I could just multiply top and bottom by something, but I really like doing it this way. As u approaches 0 of tangent of u. Also, I like that it gets people ready for u sub. Euler would have used the unit circle. Oh, I guess that's another way to do it. This is AB hamster Bing chilling. Bing chilling. That's a cool username, dog. And then this would be minus 7. Now x is now u over 3. Okay, so then here's the important thing. Divided by a fraction means I can just like put that up top. So that's going to be negative 3/7. Then we can say the limit as u approaches 0 of tangent of u over u. And then this whole identity here comes from here, so that's just 1. So then your final answer is negative 3/7. Cool. Good job, Alpha. Yeah, great. It's not that serious, dog. It's okay, though. All right, cool. That was actually pretty cool. That's a good one, though. Negative 3/7. I agree. Oh, wait. I marked yours as done again? Wait, I didn't mean to do that. Sorry. Time to shine. Sorry, I keep doing that. I don't mean to do it. I do it sometimes. I don't know why I did that. I feel like I marked it once. I don't know why I shouldn't have posted both of them. Okay, here. Let's see. Okay, cool. Or okay, for sufficiently small. What is? Let me see what Norowski's saying here. Actually, I'm curious about this. Integrate root of tan x. Oh no, that sounds complicated. I don't know if I want to do that.
Yeah, if I remember correctly, that's one of the like.
Isn't like an absolute mess of a question, dude?
Ones.
I don't want to do that.
No, God! No, God, please, no! No!
You want to do this?
No!
No.
No!
Oh no.
I imagine it is, considering I said integral of root and then space on Google, and the second thing that popped up was integral of root tan x.
It's probably one of those like notoriously difficult ones. Okay. Norowski says Euler would use a unit circle for sufficiently small t. Sine of t is less than t, which is less than tangent of t. Yes. We did see this. Sine of t is less than t, which is less than the tangent of t. I feel like there was also something here with cosine. Okay, I'll believe with that. So then what you did is you just divided everything by t. Is that what you're doing here? I think. Oh, you're dividing everything by sine. Ooh. That's even trickier. I like that. Okay, so then you divided everything by sine. So, wait. 1 is less than t over sine t, which is less than 1 over cosine t. Are you just inverting all of them? I think maybe you can do that. I think
I think our goal is to show that it's equal to 1 by saying that as cosine of t goes to 0, as t goes to 0, cosine of t goes to 1, and then we get that t over sine t has to be greater than 1, or greater than or equal to 1, and less than or equal to 1. Therefore, it's got to be equal to 1.
the sandwich theorem. We call it the squeeze theorem.
Oh, yeah.
Sandwich theorem. All right, one sec. Cosine of t goes to 1 as t goes to 0. Sure. And then tangent of t. Oh, dividing by t cosine t. Okay, that makes more sense. I was like, yeah. Oh, you're okay, Norowski. I'm the silliest. So t cosine t. I think I like this better. Okay. This is tangent of t over t. This is less than 1 over cosine of t. And then this is less than... Well, I actually don't really like what this is. This is just ugly. It's actually... I don't think we care about this, right? But I can show that... as t goes to 0, cosine goes to 1. And so, yeah, tangent of t over t is less than 1. Yes, is obviously less than 1. Okay. Got you. Now, wait, that shows it's less than 1. That doesn't necessarily show it goes to 1, right? Yeah, but tangent of t is already bigger than 1. So maybe this should be less than or equal to. Because then you always know that this is greater than 1. Wait, did we have that somewhere, by the way? We had that here, actually. Okay, so if I took the same identity, right? Sine of t is less than tangent of t. And then let's just say you divided everything by t, right? Then you get, right, sine of t over t less than 1 less than tangent of t over t. I see. So then from this, tangent of t over t is greater than 1. Here I say it's less than 1, so they have to be equal. It has to be equal to 1. That's pretty cool. Yeah, that's cool. That's cool. Yeah, maybe we should put like some equal signs on there, right? Is that chill to put some equal signs on it? Because I feel like when t equals 0, these are all equal, yeah? The equal signs are okay if we consider t from 0 to pi over 2, but I didn't do it for the purpose of dividing. Of not dividing by 0. Yeah, exactly. Okay, so known sine of t is less than whatever t less than tangent of t. I feel like there was one with cosine in it as well. Okay, cool. Let's select yours, Narosky. Let's do your question. Probably the last one for today. We gotta go do some stuff. Cool. All right. The question is there a bounded infinite sequence of real numbers, a1, a2, I guess all the way up to a sub n, for which the absolute value of a sub I minus a sub j is greater than 1 over the absolute value of I minus j? Bounded means that you should get into developing apps, man. Physics gets fun then. I have developed apps before. I mean, this whole Q system is an app that I quote unquote developed. It's really just vibe coded, but like I still had to come up with the ideas for it. Yeah, it's kind of cool. I think this is kind of like an app. It's a web app. I used to write a lot more apps when I was in high school. Okay. Bounded means there's something bigger or smaller than all values of a sub n. Oh, okay. You mean okay. Like the bounded means, I think, is it a sub I is less than m for all I. Okay, got you. So basically that like the limit has to approach something, I would assume, right? The limit as like I approaches infinity of...
Yeah, so we would say it's bounded if you can find any value, right? And m,
yeah,
that's greater than it or less than it, we call that either a least upper bound or a greatest lower bound.
Right. Is this called like the supremum? So you real analysis kids.
Mhm.
All right, let me see. It simply is as long as if I find a number bigger and smaller than its bounded, supremum, infimum are different things. I wish we wouldn't go into them.
Emotional, damn it!
Okay, that's fine. That's fine. Okay. All right. The sequence of numbers. So for which the difference between the numbers is always greater than 1 over the difference of the terms. Okay, so I don't know. Like let's take some examples, right? Well, I need something that's bounded, right? So what's a bounded sequence we know? Maybe like 1 over x squared? That's a bounded sequence, right? Or I guess you want to write it this way, right? Sum as n equals 1 to infinity of 1 over x.
It wouldn't be a sum. It would be like 1 over or 1 over.
Oh, because you're not adding them,
for example,
right?
would be you're not adding. It's just like a sequence of numbers. So like 1 over n would be 1.
1 over m would be 1?
Yeah, like 1 over n squared. 1 over n, 1 over n squared would be an example of like a sequence.
Oh, I think I... Okay,
It would
wait,
just be
sorry.
like 1 over 1, 1 over 2.
Like f sub n is equal to like 1 over n, I guess, right? Is that kind of how we would write it as a sequence? Yeah, okay, cool. But this doesn't... This is not bounded, technically, right? So we could do this. This is bounded. I know like the limit exists. Well, actually no, but you're right. Sorry. Sorry, this is bounded, right? This is bounded by 1. Can't be greater than 1, yeah? So, okay. If we were to do things, so I and j holds for all I not equal to j. So not even that they're consecutive. So it could be like A1 versus A... So, here's my other question. Sorry. The terms don't have to be in order either. So for instance, like A3 minus A1 has to be less than 1 over 3 minus 1. But also like A2 minus A6 has to be less than 1 over the absolute value of 2 minus 6. I guess the absolute value term, right, means that the order doesn't matter. Right? A3 minus A1 absolute value is the same thing as absolute value of A1 minus A3. Okay. Let's just try to... I'm just curious, like, if this even works, right? So, like, is 1 over 3 minus 1 less than 1 over 3... 1 over 3 minus 1? I feel like no. Right? Well, this is absolute value of this, yeah. Right? Because this would be 2/3. Is that less than 1/2? Nope.
Oh, brother, this guy stinks!
Yeah. If I and j are very far apart, then obviously I minus j is much greater than 1. Right, okay. So 1 over that is equal to 0. Okay, cool. Yeah, I agree with that. Oh, and sorry, we weren't showing they were less than. Sorry, we're showing the greater than. Actually, this does hold. Right? At least in this, like, rare case we have. What's up? What's up, hacker dude? 2/3 is greater than 1/2, right? Would it work the other way, though? 1/2 minus 1/6. Is that greater than 1/4? I think it is, yeah. Did I find one? I feel like I found a series. Or I found a sequence, just 1/n. Does that work?
Well, you'd have to show it for all I and J. You'd have to show that for
Every
any
combination of I
then
and J. Is this where we use induction?
these things.
I feel like this is where we use induction.
Probably. Could probably do something.
Anytime it's like prove it for everything, I'm like, okay, well, I don't have time to write down everything. So I have to use like induction to like solve it. So for 1/n, see what happens for j is equal to I plus 1. Okay, so you're saying like look at two terms that are really close to each other. So let's do, for instance, a2 minus a3. Is that greater than 1/2 minus 3? And it's not. Right? I see. Because then this is just, yeah, okay. You need the difference to be greater than 1. And that's not going to happen when anything's a fraction. Damn. Bro, use a tissue? No, my nose just itches. I'm not like... I don't have like... I keep touching my nose. Want a Monslow? Okay, so this is kind of screwed. Yeah?
Imagine an exponential might, or no, it's not bounded.
No, but an exponential won't be bounded. Yeah, that's the issue.
Yeah.
It's weird because we want consecutive terms not to be further than 1 apart. Yeah, although the whole sequence has to be bounded. No. We do want consecutive terms to be more than 1 apart, right? Because I need it to be greater than 1. Sorry, I think it's just a little slight typo you had there. That's okay. So we want consecutive terms to be greater than 1. From this property. Typing hard, bleh. It's okay. I know it's also super late for you, Narowski. I need... Okay, so wait, whoa. This starts to... Okay. If it was a sequence, this doesn't work, right? Because if I take the limit as n approaches infinity of f sub n plus 1 all over f sub n, and if this is greater than 1, this tells me right away that this doesn't converge. Right? If the next term... Oh, sorry. Nah. You're okay, Monslow. You're okay, dude. I appreciate the criticism. Sorry. It's not that the ratio of them is greater than 1. Sorry, you're right. I'm just showing that it's always getting bigger. Damn. Ugh, man. Well, wait a minute. Wait. This would be equal to, let's say, like, a plus 1 over a, right? Which would equal to 1 plus 1 over a. Okay, so that's why the series wouldn't converge, because you would keep adding 1, but the sequence could converge, because this would go to 0. Okay. No, because none of those are bounded, dude. What? How? Okay, cool. He says we kind of want to put our points in a bounded interval that rotate without repeating. That to me makes me think you want to use like sine and cosine and stuff, right? I want something that like, wait, yes, okay. I think I kind of see what you're saying. You're saying like things should be located in this like circle of life where they're always, you know, greater than like some lower, or maybe less than some upper. But like as n evolves, this thing just kind of cycles around, right?
Arctan of 2n might work.
Arctan of 2n. Arctangent is bounded, right? From -1 to 1, right?
Yep.
Okay.
The arctangent is bounded on the whole real number line.
Yeah, because arctan I think
Is
looks
it-
something like this, right?
Yeah, it goes from pi over 2 to the
Sorry, -pi/2 to pi/2. Yeah, sorry, no, yeah, no,
Yeah.
yeah. The problem is, I need consecutive terms to be greater than 1, right? But the maximum difference in arctangent
Oh yeah,
is 1.
I forgot we're taking difference. I was thinking of just
Oh no.
of just arctan.
Wait a minute. But couldn't we just put like a fucking multiplier on this bitch? Couldn't we just put like a 10 on this? Can I just choose something like large enough here?
Well, yeah, but if we multiplied it, then our other term would also get well.
No, because the other term is the indices. Right? We're just amplifying
like
the...
AJ.
Yeah, I mean, that's fine. I think the main issue here, right, is that because of this, so if I have consecutive terms, the difference between the consecutive terms has to be greater than 1.
Yeah.
And so arctangent usually could only have a maximum difference of 1. But if we just like put something massive here, now suddenly the difference is greater than 1, which is great. Love that. And it's still bounded. Interesting about the 2n though. So why'd you pick 2n, by the way, Breasticles? I'm curious.
Oh, because I was trying to think of a because at first I was thinking it was just AI, but like I was just thinking what's bounded, right? So a sub I, if we just did 1, is just like about 3/4, give or take. Which I was like, oh, that's less than 1. So I just multiplied by 2.
Wait,
Because
Narowski
arctan
says,
2 is
he
greater
says,
than 1.
oh wait, we literally can't pick any convergent series, convergent sequence. But it doesn't. No. It doesn't need to be convergent, Narowski. You just said that it had to be bounded. What's up, Alan? We're doing this little challenge question here.
But bounded
Does it
would
have-
imply convergence.
It should be bounded and divergent. No, but things don't have to be convergent
is-
because if they oscillate, right? Or
Yeah.
But I guess arctangent doesn't really oscillate, right? Or does it? No, it does, right? No, wait.
It just does
No.
like
No, it
I
doesn't.
forget
You're
what
right.
that curve's called, but yeah, it kind of just comes in, goes up, and goes straight.
Yeah, sorry. I was thinking about tangent, Narowski, not arctangent. Yeah, arctangent definitely is convergent.
Maybe like multiple, some like pi times multiple of a sine or a cosine function might work.
Mm-hmm.
Because if you think about like consecutive terms, if you do the right multiples,
Oh, you're
of
trying to
pi,
like you're
you
trying
can
to
get one
trying to
be-
hard code this thing where like it only works it smacks into like pi, 2 pi, 3 pi, 4 pi, you know.
Yeah, such that, or in such a way that 1 is equal to 1 and 1 is equal to 0. In which case, I guess 1 would always be 1.
And 1 would always
and
be
then
0.
It's always going to be less. And yeah.
But the issue is that
Because-
but you're able to pick any
Yeah.
I and any j, just not equal to each other.
Yeah.
Oh man. I'm imagining a small planet, a circle, and a little guy in the circumference. If we put a hole in the planet, he's eventually going to fall in if he keeps jumping around in one direction. Oh man.
Sine of pi over 2 plus pi n might work. Now that I think about it. Because that's going to guarantee that it either falls as 1 or negative 1.
Wait, sine over pi over 2n? It's gotta be an n,
Actually,
isn't it?
might not. Pi over 2 plus pi n.
And then whatever, just like put some multiplier out front here to ensure the difference is 1, or greater than 1.
Well, I guess that could be equal to 0. That might not.
Mm-hmm. Yeah. Yeah, because you could have it equaling the same thing. Oh no. I am but an infant crawling on the floor in this room. I feel like it too. It's okay. What's up, King Assassin? What about sigma negative 1 power I? Like this? I have no clue. Wait, what? How's the sigma function work? So then we want to
I think it means like a sum, but we're not doing sums.
What is dude doing with the gamma function? I agree. Okay. All right. Yes, Narowski, come speak, please. Help me. I don't know how to do this one.
Yeah. Sorry. I don't know either. Recently
don't
I'm
know
just
either?
looking through problems. No, I'm doing this with you guys.
Oh, okay, cool.
Yeah. So I've been thinking like for maybe half an hour on this before I submitted it. And like my main point of view was that like just now I realized that it has to be divergent and bounded. So the only explanation I have is that it has to be like circular in a way.
Okay.
So that's
Which I think-
that's where my analogy comes from.
I liked
with
this. Like it's like
Yeah.
running around something, right? So it never
Yeah,
converges to a
imagine,
single
like-
number, but it's bounded.
So imagine you are forced to jump forward on a circle
Okay.
each time by a fixed value, right?
Okay.
So if you're jumping with a fixed value k, depending on what that value is, first off, if it's an integer, you're always gonna just jump in the same way, right? So you're never gonna you're gonna hit the place you started again at some point,
Right. If it's periodic.
right? So
If it's periodic with an integer.
your trajectory is fixed. Yeah.
Right.
So your trajectory is fixed. At some point, you're gonna loop back around. But then again, if it's not an integer, you have the choice of it being either rational or irrational, right? The jump you're making. Again, if your jump is a rational number each time, and the same length again, you're gonna hit the same position you started in. But
Unless
is that true if it's not rational?
Right. Yeah. If you just had like sine of n, right? For instance, you're never
Yeah.
gonna hit yourself again, right? Like, sine of 1 will never equal like sine of 420 or something.
Well, it's gonna. No?
If it's integers?
Sine of 1 is gonna be sine of 361.
Sine of 1 is equal to... I was thinking if... But if it's in radians, no, right?
Yeah, not in radians.
Yeah.
In radians, yeah. But then again, in radians, isn't it irrational?
Correct.
Because
Yes.
it's dividing by pi.
Yeah.
Yeah. So here,
Okay.
that's my point. Yeah, if it's irrational, then I think we have what we want, right? We just want it to be irrational.
I agree. Yeah.
Our jump has to be irrational.
But how do I ensure that the jump is always... It has to always be less than 1, I guess, right? Wait. Oh, man. It has to be greater than 1. Oh. Yes.
So
This will at its
yeah,
maximum
let's
be
say,
1. At its minimum, it'll be 0. It'll be 0. So I just need to ensure that the
Yeah.
jump is always greater than 1, and then we're fine, right?
yeah, so let's just have like jumps of length k,
Yeah.
each one irrational. Our
Yeah.
k is irrational.
Sorry,
But then
K is
what
irrational, right? Is what
Kind
you're
of
saying, right?
sequence are we choosing? Yeah, irrational. Yeah, our jump has to be irrational because then when we look back around the circle, it's not gonna land us in the same position.
I think I want to do like
If-
a
so-
million like sine of K, sine of X. I feel like that's what I want to do.
Oh, what if on like the east part of our planet, like where Japan would be, like where
Sure.
the sun shines, right on the exactly right there. Yeah, let's just say that's 0, and on the other side should be a half. No.
Okay.
So then we just have the interval from 0 to 1 just looping around itself. And what else? So what else behaves like this?
I want to say trig functions. That's what I think about. Or maybe maybe with Euler, maybe e to the pi I. We could do this as well.
Trig functions go to -1, so it's a bit bigger if we choose trig functions.
Alpha
What
says
about
-1 to the I.
numbers?
They're saying this. But how do you compare the distance between imaginary numbers? I don't feel like you can do that, right?
No, I think he's just saying it as an index.
Yeah, I think it means I as an index.
Oh, I as an index.
But the problem with that is, because this is what I've been trying to think of. Like, I can think of a ton of solutions if we specifically say that, I and J are not the same.
I think this is the issue, though, right? Because if I and J is 2 and 4, this doesn't work, right? Because then this is the same thing.
Yeah,
then the difference is 0.
That's a counterexample. For every even power, the difference is 0, so it doesn't work.
Well,
Quite the
the
alpha, though.
difference is 0 for anything where they're both even or they're both odd.
Yeah, so
if
I
it
think
were 3, then you would have -1 and -1.
so. I think they have to be irrational. The distance it jumps has to be irrational with n, then, right? Or with
Yeah. Oh, so then we jump.
because we never want to jump to the same place, right? Because then we screw ourselves.
Yeah.
But we also
'cause then
want
it's-
the jump to be a
exactly.
minimum distance, so that I can just like slap like whatever number in front of it to ensure that it's greater than 1.
Okay. Can you draw from 0 to 1 like an axis, a bit like
sure.
a bit of a bigger axis?
Yeah.
Yeah. Because we have the circle and the axis, so we're just like stretching out the circle.
Okay.
So every jump we're making is k, right? So if let's say our k is irrational, all right? So after we reach number 1 from 0 to 1, we're gonna go back around, and it's gonna be in a different spot than when we started, because just basically with pure irrationality, it's not allow us to go back to where we started.
And I think we have to travel further than 1 Nurowski though, right?
Yeah, exactly. So that's what I'm saying. So when we reach 1 and when we go past 1, let's
okay, I
just
got you.
go back to 0.
I see what you're saying.
Yeah.
So we would come back to 0, but we don't want to do that. So we want to come here and
Yeah.
like come like slightly a little bit further. Like maybe like right here.
Yeah. So let's say we start at 0. We're gonna go towards 1, and when we reach exactly 1 or go over it, overflow, the overflow is gonna go back from 0.
Yes.
Similar to a trig function, yeah.
0.3 or something. Example.
Yeah, something.
I think if
So
we can
then-
somehow like mandate that there has to be some minimum step that it'll always be away from
Oh,
0.
you know what happened? You know what?
What's up?
Yeah. You know what behaves like this?
Hmm.
The what do you call them? The decimals after they're the fractional part.
Okay.
So the decimals after a number. This is what happens. So when let's say we have 1.5, if you add 0.7, it's gonna loop back around to like whatever it is.
Oh, sorry, 0.7.
Yeah.
Well, this would be equal to 0.2 then, no? Right? Or no?
Yeah,
This
the
would be-
fractional part. Well, the floor is.
Yeah, sorry,
2.
sorry. Yeah, not the floor.
is
Sorry.
2.
Sorry. That's like this thing, right? Is that what you say? Like,
Yeah.
and this is the same
You
thing
can
as like.
notate it how you want. Yeah.
I think this is the notation, right?
Yeah. Yeah. It's the same. thing.
Okay. Got you.
So this is what we want.
Okay.
Okay, so then let's try. Oh, I was gonna say something stupid. I was gonna say let's try our.
Ooh, no,
sequence
I
to
like
be
this.
Just,
Wait. I like
the
this.
fractional part.
What if we do this? What if we say this is just equal to, yeah, just the fraction. Sorry, what am I trying to say here?
Fractional part of our jump.
Yeah,
no?
fractional part of the jump. Right. Yeah. Okay. But if we just left it like this, the fractional part would always be 0, right?
Yeah. So then we want to multiply it by how many steps we're making. So times nx. Yeah. Okay.
It's still gonna be 0. So maybe we want something like this, like 1.2
No, because n is arbitrary.
plus n over 10x or something.
Yeah, it doesn't matter. Yeah, nx is kind of the same thing. Because our jumps are basically 0, k, 2k, 3k, where k is irrational. At some
Right.
point, it's gonna loop back around to 0 and past 0 again once it reaches 1. So it's exactly the fractional part of a number.
Oh, it's just fractional. It's literally just that. Yeah.
Yeah, it's just the
of
fractional part
nx.
of n times x. Yeah, because how many steps we're making times the irrational number. X has to be irrational here.
Yes,
And
I agree.
n
I
has
agree.
to
I
be
agree.
an
I agree.
integer. Yeah. Okay, so this is what we're looking for. Kind of. It can't be that, let's say, if we're checking if our condition is met, we just don't want it to visit a point that has been visited before.
Right.
So then, if we equate ix equal to jx, for example, that would mean that I minus j times
Is
x
0.
is going to be an integer.
Yeah.
Or just an integer. Yeah. So which
Okay.
isn't true because x is irrational. So
I have to have like some idea on like what's the minimum difference though between things,
yeah.
because I need the difference between any two terms to always be greater than 1.
Yeah, this basically just says our point. The way we choose our points. This is just density. If you're familiar with the concept of density.
Mm-hmm.
So we're just finding numbers bigger and smaller on the circle. But we need the difference to be greater than something
One.
over the absolute value. No, because 1 was a happy example that we had before. If you look at the problem, what it's asking, we want the difference to be bigger than something over I minus j or something.
Right, but I'm saying that
Yeah.
the smallest the difference can be is equal to 1.
Yeah, sure.
Right? Okay.
Yeah.
Well, yeah. If we want to ensure it works for all values, because if they're consecutive, then the difference will always be equal to 1. The difference in
So we just want to pick. Yeah, we just want to pick an x that works for this.
Mm-hmm.
What happens if we replace like a sub something in our problem with the fractional part of an x?
Okay.
But I
So you want
didn't
to say
try
like
this.
a sub n times x?
I'm not sure what we had before.
But we just said n times x for the fractional part.
Yeah, but I meant to replace n times x in the fractional part into the original problem statement.
Oh,
You
okay.
know,
Sorry.
so-
Let me pull that up.
Our sequence is n times x in the fractional part, and we want to replace a sub I and a sub j with
Gotcha.
I times
I
x
and j.
and I times
I see.
x.
You're gonna substitute
Yeah.
that. Okay. So from
Yep.
this, you want to say that.
Our sequence is just nx. Yeah. And
Yeah. So you're gonna say
yeah,
ix
in the
fractional part minus jx fractional part has to be greater than 1 over absolute value of I minus j.
Yeah.
Okay.
or some constant over. Yeah. Could be one.
Okay. I can't pull out the x, right?
No.
Right? Yeah.
So
Because fractional part of I would just be 0.
what x do we pick here?
Yeah, that's a question. I want to say it's like a sine or cosine. Like, I only know so many irrational things, right?
I mean, any square root is irrational if it isn't
True.
a perfect square. But
Oh,
what
I see.
square root?
Like square root of 3 or something?
X to the 1 over x is going to be irrational for any n greater than or equal to 2, but it's not oscillatory.
Yeah, it's a problem.
Yeah, we need it to oscillate, right?
Yep.
Wait, but
Because then it's either gonna converge or diverge.
wait, doesn't the fractional part though kind of? Oh, I see. Never mind.
No,
Yeah,
because it's
yeah, I
irrational.
got you.
Yeah, that's what I was struggling to explain. Because if we picked anything other than an irrational number, our sequence was just gonna converge because our jumps are gonna take us to the same spot we started in.
Mm-hmm.
Yeah, I know. Square root of 2, maybe 3.
Square root of 2?
2, 3,
see.
I don't know. Small
fuck it.
square roots anyway.
Okay. So I times the square root of 2 minus j times the square root of 2. Okay. So if I had 2 square root of 2 minus 3 square root of 2. Alright, sorry. Alright, 2 square root of 2 minus 3 square root of 2. Yeah, the difference is a square root of 2. But wait, the fractional... Sorry. No. 2 square root of 2 and 3 square root of 2. What's it like? 2.8 minus 4.2. The problem there is the answer is 0.6. And that's not going to be greater than 1. So this is my issue, is that like if I get to higher and higher ends, oh, I see. But wait a minute. Wait, 0.8. One sec. Let's say I had 1,000 square root of 2. Minus 999 square root of 2. Yeah, it's always gonna be a square root of 2. Yup. And that fractional part
Okay.
would be 0.41.
The difference between any two fractional parts in this format, so
Has to be
I
less
and J,
than 1.
right? So
Right.
Yes.
Okay.
How do we write it as? Not sure. So the difference between any two terms is ix minus jx, both in fractional parts, right?
Mm-hmm.
Which is what? If we say maybe n is equal to I minus j,
Okay. What's up, JC? We're doing a stumper of a question, JC. Okay, n is equal to I minus j.
so then ix minus jx, both in the fractional part,
Okay.
is gonna be n times x minus something, minus a constant.
Wait. You want to substitute that in for here? You say, wait, I is equal to n plus j? No, it is Lionel. Don't worry about Lionel. Yeah, this is a challenge question. This is kind of a fun one. It's a brain tickler for sure. N plus
this
j.
is more like guessing it instead of anything else.
Yeah, we are really just guessing. Wait, but then
you know what you're using.
what's up?
We're not using the definition of what the fractional part actually is.
Oh,
you
with
know,
floor?
instead of working with fractional parts, we can just
We should
work
be
with
working
the
with
number.
floor.
Yeah, the number minus the floor. Yeah,
Okay.
I think that was our mistake.
Okay.
Yeah,
So
so instead
this-
of the fractional part, we can just write it as ix minus the floor of ix.
Mm-hmm. And then we say minus jx plus the floor of jx. Right?
So this is, if we factor everything out, this
Yeah.
is just going to be x times I minus j.
Mm-hmm. And then
Minus the fractional parts subtracted.
So minus
You know,
floor of
'cause minus,
a fraction.
yeah, in quantity, minus quantity. Yeah, sorry, minus, yeah, the floor. Minus quantity, the floor. the difference of the floors.
Oh, it's a one sec. Lionel, my background is physics. I have a PhD in physics, Lionel. That's my background. Nuroski is a Romanian vampire that just knows a lot of math.
My man.
And he's won some cool math competitions.
Yep.
Okay, so wait. I see minus quantity. That's going to be, yeah, IX floor minus JX floor.
Yeah.
Okay.
So if we just let that entire parenthesis of the difference of floors be like n, for example, or m.
Mm-hmm.
And
this
I
is
minus j in this case.
Yeah. What are you gonna call this?
It's an integer, right? I minus j. So
Yeah, I
let's just
agree.
say
This
it's
is
like n
this is
or
an
k.
integer.
So n or k,
Let's use k. We have,
whichever one you like. Yeah. So then
I like k.
the difference of two terms. The difference of two terms is just kx minus n. It's always going to be of the form kx minus n.
This is so. This whole thing here is gonna be kx minus n.
Minus m, or
M.
the next.
Yes, I got you.
Yeah.
Okay. Sorry, all of this is okay. Got you.
Yeah.
And then m is always less than 1.
Yeah.
Okay.
It feels like we're getting somewhere.
And that integer. Okay. And wait, k is
Okay,
always greater than
so-
k is always greater than 1, right?
Yeah.
Well.
Yeah.
Or just not
'Cause
equal
I
to
is
0, I guess.
bigger than j.
Well, it doesn't have
Yeah,
to.
I is bigger than j, so it's gonna be bigger than 1.
Be. Okay.
Because I and j are integers, so yeah.
But technically, you
Yeah,
could
yeah.
pick whatever, right? Isn't that also kind of like the whole point of this problem? Is that... Oh, I guess once we get to the absolute values, it doesn't really matter whether you swap I and j. It doesn't matter if I or j are bigger.
Yeah, it doesn't. Yeah.
Okay.
But for the simplicity of the problem, yeah, I can just consider I is greater than j.
Okay.
They just don't
Okay.
have to be equal. Because if they're
Okay.
equal, then it makes no sense.
Okay.
Um.
And I think we just have to show, again, that this is all just greater than 1. I think it's all we have to do.
That entire
And it has to
thing,
be
yeah,
irrational.
Greater than? Yeah, I get it now. Because
Yeah,
we
this-
want the distance between the terms I and j, so AI and AJ,
Mm-hmm.
is basically just how close kx can be to an integer. Because x is irrational, how close can it get to an integer?
Okay. Okay.
Because then the absolute difference, yeah, is gonna get closer to 1 over something.
Mm-hmm.
Because at that point, we're just gonna have the difference of basically two integers, because kx is gonna be close to an integer, and m is already an integer. So then we want that to be greater or approximately 1 over an integer.
Why is m
Because
going to be
I
an integer?
minus,
Why is m going to be an
minus j.
integer?
because the floor of something is always an integer, and m is the difference of two floors.
Sorry, you're right. Yeah, you're right. Yeah. I was thinking it was the
it's gonna
fractional
be-
part again.
It's gone on for a while.
Yeah.
Yeah. It's okay.
Always an integer. Yeah, got you.
So then. Oh, and this is greater than 1 over k, because we had the condition of it to be
Good.
greater than 1 over I minus j.
1 over the absolute value of k, technically.
Absolutely, yeah, technically, but k is greater than 1, so
Okay, sure.
doesn't really matter. So we wanted to get as close as it can to this 1 over k. So at this point, we just have to check for values of x. Maybe. No?
Mhm. K can be any integer.
We wanted
Okay.
square root of 2, maybe?
Yeah.
Yeah, any integer.
I think we wanted the square root of 2 for x. Sorry, yeah.
At some point. For x, yeah. So then k squared root of 2 minus m?
Is that always greater than 1 over k?
What if we amplify
K is an integer,
it
though. Yeah.
by... Yeah, it is. What if we amplify the right-hand side? So we multiply by k squared root of 2 plus m and divide by k squared root of 2 plus m.
K squared.
Not the right-hand side, the left-hand side. My bad.
What do you want to multiply here by?
The left-hand side by the conjugate. So k squared root of 2 plus m.
Gotcha.
And you divide by it.
Mm-hmm.
Because it's going to be a difference of 2 squares. So we just get rid of the square on the top.
Gotcha. Okay, yeah. All right, so this would end up being 2k squared minus m squared.
Yeah. Over whatever. Yeah.
Mm-hmm.
I'm pretty sure we already know that k root 2 minus m is going to be greater. Because if m is less than 1, then root 2 has to be greater than 1. So k multiplied by root 2 is always going to be greater than 1.
Okay. So is it always going to be bigger than 1 over k?
Well, 1 over k is always going to be less than 1.
Integer.
Yeah, 1 over k will always be less than 1, right?
Yeah.
At most, it can be 1.
At most, yeah, 1. And that's only if one of the indices is 0. And the other one is... No, actually. If the space between them is 1.
Yeah. Yeah, if they're consecutive. Okay.
Oh, yeah, if they're consecutive. And we already checked if they're consecutive.
Yeah.
If they're consecutive, they can't be equal to each other.
So...
So is that it?
Yeah, I think it's just square root of 2, right? Or wait, what does k need to be? Oh no, k was the difference in the things. Okay.
Yeah, right.
Okay. So f of n is just equal to square root of 2 times n. Is that really it? Oh no, wait. No. There's a floor function.
In fractional part.
Yeah. Square. Yeah, that's.
I
Yes.
think we could take any square root as long as it's not a perfect square.
Let's ask chat. Let's ask the AI. I'm curious. This is cool. I like that we went through and defined all the equations for this.
GPT gives for this.
Yeah, let's see.
Yeah, I haven't given any AI this problem so far.
Let's give it the whole.
So
let's give it the big one. I'm gonna give it the soul high. I'm gonna say like, I think a solution.
I'm curious what it would have said if we didn't give it the handout.
Okay, I can do it too. Let's put on the regular one.
Yep. I'm curious if it's gonna be able to solve it.
I mean,
if you just give it
solve the
no handout.
Poincare conjecture or whatever. I think it can do a lot of stuff. Mathematics is like kind of freaking out about AI right now. Wait, not the the Poisson Poisson conjecture? Is that what it was?
No, the Jacobian.
The Jacobian.
Yeah, the Jacobian. I did some other stuff.
But I really just like found a hack. Just found a counterexample. Okay, you're very close. The fraction parts alone, n squared root of 2, did not work. Because a sub n is defined as 0 while the convention requires.
Oh.
But the scaled version works.
Oh, so we just need a scalar.
Oh, okay.
Yeah, we know this, but it's. Well, what's the
I see.
point of multiplying it by 4?
This is bounded since a sub n is between 0 and 4. Yeah, why doesn't he be bounded by 4? Is at least one. Worked for 37 seconds, yeah. We worked for like 37 minutes. Wait. I'll ask him.
I get that it cannot be. I get that 2k squared minus m squared cannot be 0, because then square root of 2 is an integer, which is very fake. Like, I get the reasoning. That's what I was trying to get to.
Mhm.
But I'm not sure how it jumps to the conclusion that it needs to be scaled by 4 after that. But I understand it has to be greater than 1. Or equal to 1.
The scaling is necessary because in the original the original fractional parts all lie in 0 to 1, which is impossible for two numbers in 0 to 1.
Okay, just because. Okay, because it says so. Okay, so there's no point of it being 4.
Oh, C equals 3 also works. Okay.
Yeah, okay.
Yeah, when I
Yeah, I see.
asked it, it just straight up said because the fractional part sequence by itself is not separated enough.
Oh, because it gets too close?
Yeah, I guess so. I guess it kind of just chose 4.
Oh, but 3 works as well. Okay, cool. All right, we did it. Wow. That was fun.
That's good.
It started making more sense, definitely, towards the end. But I appreciated the workout, the struggle of, like, trying to figure it out ourselves. And I think it was cool to, like, think about it in certain ways. Like, this was cool, the oscillating thing. And then we're like,
This
oh, what about
is
fraction?
basically like a walkthrough. This is a walkthrough of how you would solve a competition problem. This is really intuitive, yeah.
Yeah. But it's cool to I liken it to going to the gym because we didn't look for the answer right away, right? We had to like struggle, and the struggle is how you get better at things. Yeah, we struggled, bro. We struggled for 55 minutes.
Yeah.
Oh no.
we spent a whole hour on this. Oh my god.
Honestly, that's really good bait.
Oh my god, dude. Okay, I'm exhausted. Okay, I'm closing the stream. Okay. All right, thank you everyone for coming to Actual Education Office Hours today. This was fun. I will say the time went by really quickly, Narosky. It's it's like time flies when you're having fun. But yeah, oh man.
Yeah, it's like you're sitting down at your desk and you say like I'm gonna solve this, then I'm gonna go like do something else, and then you look at the clock and it's like 5 hours has passed.
Thank you, Flask. You're welcome. Very welcome for the stream. Thank you for coming by and hanging out with us. Yeah, we had like a fever dream where we just looked up at the clock and we're like, oh god, it's been an hour.
Yeah.
Oh no.
Emotional, damn it!
Thinking
Right.
about little people on planets on a circle.
Hopping around and stuff.
You know, it really gets the time going. Yeah.
It really does. Yes, Lionel, tell people that met us for the first time. Welcome, guys. We're not the only people that do this. There's a whole other great conglomerate of math streamers. Here, I'll dump there's all their usernames if you want to go follow them. They're great. And then also we have a website that has a calendar when everyone streams. So if you go to that website, you click on the streaming schedule. There's also a cool little calendar here that shows all the different times other math streamers are on. So my last stream before I go to Burning Man will be tomorrow, and then I really got to start packing and stuff. It looks like the next week is kind of open, but then Zach comes back. Zach comes back in early September. I do need to hydrate, thank you. And so then we'll have more people streaming and doing fun stuff. So go check it out. What would happen if I was stuck inside the LHC while they turned it on? Would I become Dr. Manhattan? Yeah, you can get Master Chief coming out for you. Oh, I don't know. Great show, though. I love The Watchmen. Great animated book. I don't want to call it a comic. It's not a comic. But, there's a comic in it, though. Okay, let's go raid someone. Let's go say hi to somebody else. And I'm going to go, like, dunk my face in some ice water or something. I feel like I just went to the math gym, dude. It was so fun. All right, let's see who's on. Someone's doing a KBBQ stream. Oh, that's gonna make me hungry. Cool. Let's go say hi to Science. Science is doing, looks like an interview with someone. Helen Anderson. She looks cool. Cool. Go say hi to Helen for us. Looks like a scientist. All right. Enjoy the rest of your Monday. We will see you tomorrow for last stream for a couple weeks. So come on by, say hi. Peace.
There's protection for that.
And that's at least the U.S. base, but international.
Summer is back, along with Chipotle Honey Chicken. Fresh grilled chicken,